Hi there, and welcome to my podcast. Focuses on environmental sustainability, education, AI, and beyond. In today's episode, I had the pleasure of speaking to Titusz Ban, a software engineer at Trayport. Previous Shockstock president and University of Leeds student, Shockstock is the Electrical Engineering and Mechatronics Society at the university. Titusz and I crossed paths on the project of Shockstock, which more information can be found out in the description. It'll take you to a Wix website, and you can see the focus of the society. So he shared his insight on leadership, aided the focus for the society, and also touched on many other topics surrounding university. So I found this very useful as a first year, because this interview took place last December. Since then I have been inspired to become a mentor, and I very much hope that you enjoyed the interview as much as I did.
Yeah. Well, hello, Titus. And
Hello.
is that how I pronounce your name? I didn't ask beforehand.
Yeah.
Awesome. I'm Donny. Just it might be easier than Donat. And yeah, I would just like to fire off with the first question, which is to understand who you are today and where you are today, what you're up to. What would I need to know about you that are like key specific defining factors in your life? That's worthwhile mentioning, if that makes sense. Friends, family, things that happen to you, maybe that it's good to know, to understand who you are today, if that makes sense.
Sure. I mean, so I grew up in Hungary until the age of 19. I was there. I did primary school, high school there. Came to the UK, come to the University of Leeds, did a integrated bachelor's and master's in mechatronics and robotics, did a placement year in between, and now work in software engineering and software engineering consultancy and that kind of things. Yeah, that's mostly it. I am engaged, have a cat, which is very nice. Yeah.
Awesome. So sort of the educational background. Okay. I was later on gonna ask about sort of the differences that you found that in Hungary as well, and sort of as if it's comparable, but of course at different points in your life you were at high school. Right. So I suppose I'm curious about sort of if I'm asking sort of a hobby sort of thing. It's like software development on the side as well, sort of on a hobby level, or sort of things that you get up to, sort of.
Yeah, I mean, it's somewhat blurry because I have my day job, I have my side hustle, and beyond that, time is somewhat limited, and so a lot of what started out as hobbies, side projects, side hustles, kind of ended up being a more full-time job. So what's little left in time, I like to read, mostly audiobooks, although I had much less time this year. I play video games, I play board games. I picked up lockpicking for a while, but that maybe because it's a very nice fine motor skill and it's actually a fascinating mechanical process, but I don't have that much that much practice and don't have that much time to practice. What else do I do as hobbies? Yeah, I do some smart home stuff, but yeah.
Awesome, yeah, because I've seen the on your profile at least the two freelance jobs sort of started beside the day job as well, sort of thing. That's interesting. Sort of, it started off as something that you were just interested in, keen on, and then it just became sort of went into it further, or how did that come about?
Kind of like, or it happens through contacts where like, ooh, can you actually do this thing? It's like, yeah, I can probably do that thing, and then, ooh, do you want to get paid for that? And yeah, it kept paying, so I kept doing it. Yeah.
Awesome. I'm also curious, sort of common questions from friends of mine. I think that they're romanticizing it a bit, very mystical sort of thing. What is sort of like
Hold on.
sort
Sorry, I
of.
didn't get that question. You're breaking up a bit.
Oh yeah, no worries. I was just sort of leading up to it. So some of my friends in my robotics team, they're curious about what sort of you use for time management or sort of how you plan sort of thing. Your I suppose your work output. I suppose that they're interested in. We all seen the suggestion on the on LinkedIn, and they're all from Craig Evans. That one. I'm not sure if you remember that one. Do you remember that suggestion? Yeah, that's quite seen quite bigly at university.
Interesting. Yeah, it's. I mean, it's a two-pronged thing. There's some amount of tooling, nothing special. I use Google Calendar for everything. I use Notion for just keeping things organized. I have tried some way too expensive tools for allowing you to schedule and time manage everything very well, which is very nice, but as I said, way too expensive. So just having everything in my calendar time boxed, which obviously isn't foolproof. There are some things that overrun. There are some things that that just pop up that have to be dealt immediately, which obviously happens. And then there is some amount of overhead on replanning. What I also do is I have essentially a Kanban board for personal to-do list, which uses it's a Kanban method. So I have an incoming pile that I pull things off of. It's also frequently used in software engineering, and essentially try to finish what's already in flight before picking up new things, keeping work in progress limits very low. I have two of those, one for personal work, one for household and that kind of things. But that's useful, but it's a lot less about tooling and a lot more about sort of discipline is too strict word, but it's more like self-management. Things that I very much didn't get the first few years of university was really my placement, and having a 9 to 5 job that I need to. It is pre-pandemic, so working from office every day, and having to get up on time, show up on time, but then having the opportunity to that being a fully contained experience where that ends and then can do other things. That was something that is quite eye-opening. It was coming back to university the year after, seeing that what seemed like a daunting amount of work at university. Yeah, if you do that, if you have a good night's sleep and get up on time and get started, 8 hours is quite a lot of time, and you can just get most of that done and then do other things. So that was quite helpful. It is extremely basic. Sorry, there is no big wisdom here, but it is something that I have found quite useful. And that does allow you to start to build habits on top of it, because if you are getting up on time, then you can do work at physical exercise, just going for a walk or going to the gym or going for a swim or whatever. And you can build helpful habits on the other end of that once you're done with work, do useful things. I say all of that. In practice, that is always a constant struggle of, yes, but being lazy and letting your sleep schedule completely flip around and playing Stellaris until 3 a.m. It's something that is always a balancing act. It's something that always has to be the responsible way of doing it, and whatever you want to be doing, there's always a trade-off there. But it does have with productivity doing this the right way.
Right. So it was something that you had to really pick up on in the, I guess, in a professional setting prior to, it was one step still different to what university is like, or what you may have. So the how should I say, the more structured, maybe more. I've heard this from a couple of people. They come back and the university work may seem easier than it did beforehand, because because they had to self-manage at work with the work that they're doing, what they're focusing on, the projects that they may be doing. So that's interesting
100%.
that you mentioned that. That's interesting. Right. Okay. I also wanted to ask about this. I've also seen this on your profile, actually. This RESAP, I think in 2015 or so. Could you explain something about that? I think it's a robotics competition.
So this is the first Lego League competition. The team itself ran by many names every single year. The one that was successful was RESAP or RESAP. It's a dumb name, but SAP was a sponsor, and so they had to be in the name. And this was that year. Every single competition has some kind of theme, and the theme for that year was recycling. So, hence the name. So FLL is it's an international competition. It's unfortunately not huge in the UK, but essentially it's. I think the age cap on it is 14. There are a few more advanced versions of it, but essentially you have a 2 meter by 1.5 meter board with challenges on it. You are building a Lego Mindstorms robot to run on that in a very strict time limit, and there are some side events. There's a project that you're running. You're also assessed on robot design. You're also assessed on teamwork, and it's one of the few large-scale robotics competitions that, as a early teenager, you can get into. And I was extremely fortunate at the high school I went to had a robotics society and had and sent various robotics teams to these competitions, and I joined them year 9, which meant I was able to compete for 1 or 2 years, and then and those competition years, there was essentially a major generational shift where the previous team has just finished and wasn't really interested in coaching us, and so we had to pick up all of the learnings from ground zero. And so the first few years very much just that learning experience competing. But as I aged out of the competition and shifted more towards a mentoring and coaching aspect, that is around the time when the team started to become a lot more successful. We have started winning the national rounds, the European rounds, and the final year when I was at high school and when I was still taking part of this was the year when we won all of those rounds and then qualified to the. Actually, win is a stretch. I think we came first in the Eastern, won the Hungarian one, won the Eastern European one, and then came second in Europe, which meant we qualified for World Nationals in the US, which was a fascinating experience. Being in the US in general was very interesting, but also in the US, this competition is done on a very different scale, especially compared to Hungary. And so we were nowhere near, we were absolutely bottom third of the table, but the experience itself was exceptional. Having seeing robotics done on that scale, but also the achievement of we were the first team from Hungary to ever be there. And while we weren't really a serious threat, it was still really exciting to be there. Plus the logistics of flying massive Lego robots in suitcases across half the world was, that was also quite fun. But potentially more importantly, this competition and this robotics society is what got me interested in obviously robotics specifically, but programming in general. Before that, maths education was excellent in my primary school, but science was not, meaning I wasn't really exposed to STEM things early on. And so this was really the first thing that exposed me to the idea of computers are more than Excel or whatever is in an IT class, and that you can program things, but programming things more beyond the basic command line application and more to the, yes, I can actually make things move and happen in the real world, but also seeing the complexities of interfacing the real world that is so much more broad than the narrow domain a lot of the early programming exercises actually expose you to, because sure, you can calculate a prime number, but those are very much a constrained problem set, while running a robot on a board, you run it 10 times, you will get 10 different results, and being able to account for that and being able to have to plan for it and have to think about solutions that can scale into that complexity domain is a lot more interesting. Also related to, around this time, once this exposed to programming, I also did some game development, because as a teenager, video games are fun. And it also has very similar characteristics where the actual problem domain is a lot more broad, but you can also do a lot more interesting and a lot more challenging things. And so that was absolutely crucial to my early education in computing, which obviously I kept up and keep doing.
So that's when you started self-teaching as well. Sort of, I've read something about this as well. Sort of more in your own time, sort of looking into it, researching. Around the time?
Yes,
this was happening.
So so specifically how it happened is that the teaching around this robotic society wasn't really something that happened. We had teachers who were technically running, but they were a lot more administrative, and there was very little practical hands-on teaching, but it's more go build this thing and figure out how you do it. Yeah. And while I came in originally as not sure how much you can see from my background, but I do quite like Lego, and so I came in building things, but I always had to rely on others to do the actual programming to do the project. So I had essentially enough of that, went and taught myself in a weekend how to do the very basic programming for these Lego robots, which kind of started if I can learn this by myself, I then went and learned how to do the same programming, but with a weird C-like language that compiled into the same thing, and then went on to then learn C#, and then went to learn Lua, and went to learn a whole bunch of other things, and just kept teaching myself things that I found or things that I discovered. It's a very interesting thing of learning, especially in the self-taught manner, is that you don't realize how much you don't know, obviously. But the more you learn, the more things you discover as things that you don't know, but you now know exist. Essentially, it's a the discovery frontier of the previously unknown. And the more you do things self-taught, the more you can think I actually want to go and learn that next, and I'll go and learn that next, and they just kept extending. That's how it went from learning a few basic programming languages to learning C# more in depth for Unity and making games, and then C# ended up being constantly useful. And then this is similarly going and learning Python, because it seemed like a fun language. And so it starts with it starts just with what you can understand to learn. Learning new languages is something that was not easy to do, but an obvious thing. But you also start to realize that the disciplines within that you can start to self-learn those as well. And this is somewhat related to why I ended up doing mechatronics as opposed to let's say computer science, is that because I was in the constant groove of learning new things, computing, and I found that easiest to do with computing. It's a lot, although it is a lot easier now than even let's say 10 years ago to learn hobby electronics, but realistically what was an option for me is learning computing myself, and so doing mechatronics in a more formal environment where I do get to learn the electrical engineering and the mechanical engineering and the bits of computing that are specific to mechatronics, such as the AI and the robotics side of it, while keeping up the self-taught side of software engineering, that has been a quite beneficial balance for me. That said, there are limits to that where there's only so far self-teaching will take you. That was one of the rationales why I did a placement at a very like Trayport, where I did my placement and where I have my full-time job now, has nothing to do with robotics whatsoever. It is as far from robotics as it possibly can be. However, it is an excellent software engineering company, and so the things like can't or things that are very difficult to self-learn, things like the practical differences between what is software engineering and what is programming, and the things that you just don't necessarily get exposed to if you're trying to solve specific problems, as opposed to learning how to write better software, for example. Those things were the things I could learn from going into the industry and doing software engineering professionally.
Yeah.
And so that was also an excellent learning experience, that there are some things that you cannot, or that is a lot more difficult to self-learn because you're not necessarily exposed to it. Things on the procedural, the process side of things, and things on the, I guess, software engineering management side of things.
Right. I see what you mean. And then you could also, what is it also arguable that when you're learning programming, you're in this specific, I guess you're just when you're self-learning, you're learning within that domain only, aren't you? And within software engineering, you're learning more of the process as well, how to apply it elsewhere.
So, kind of. So it's very easy to focus on just the problem you're trying to solve. Whether that be robotics, game development, general programming, what have you. There are a million and one things that you might want to do, but you will not necessarily get exposed to other parts of software engineering as part of this, and you may not get exposed to, especially if like a lot of the practical learning is from stuff like Stack Overflow, you might find the specific answer that you're looking for, but you don't find but you wouldn't be in this situation if you followed some principles that are well known to industry. But that said, that doesn't mean that self-learning doesn't generalize. Something that I have found constantly joyful is things that I discovered or invented myself, very heavily in quotes, because obviously this is just the first time I have solved that problem. Seeing that solution in a more formal environment, whether that's like learning about data structures and algorithms, and saying like, that's what I have solved, that this is very similar to how I solved it. That is a very nice thing to see, that where you arrive from a very practical, hands-on, self-taught can be similar to the like somewhat more formal learning or the more like structured learning, but yeah. So there's some amount of generalization there, but there are limits to that. Like things like Agile and Kanban, those are I was not exposed to until I went into industry. This is even before Trayport. I did 2 summer internships, which were excellent. But yeah, those were like, and that organization wasn't really even doing this. Is more them discovering this as well. But that was an environment where discovering things on the process side is something that is done. Which, well, obviously, if you're doing things on your own, you wouldn't necessarily do. But in a, let's say, team setting, I have brought in a form of Agile to my 4th-year team project, and it was a roaring success because it gave the kind of loose but still existing structure that can work very well, especially in a software-related or a like software-like environment, which may or may not be a perfect fit for other engineering, but it is something that you wouldn't really be exposed to from an engineering education or from a self-taught point of view.
Interesting. I just thinking of we were also mentioning and pinpointing the Lego aspect of when you were interested. I'm just curious of what aspect of the build, or what was it that really interested you actually in the engineering side, or just if you can pinpoint what was fulfilling or even interesting to you merely, if that makes sense.
I don't think I can necessarily pinpoint something specific. It's like Lego was more a bridge to make it easier to get involved. If you're like jumping into something that you know absolutely nothing about, and you have a very steep learning curve ahead of you, that can be psychologically daunting and just very easy to burn out. But if you have something that you already know and understand, in my case that was Lego going into robotics using Lego, that was essentially a way to easily essentially have a thing that I was very comfortable with. Like, I can build complex structures that do things that are practical, that are modular, although I have learned a huge amount about it as well. But I had a place I was comfortable in, where that allowed me to have that place of comfort to go and realize the things I don't know, realize the things that I was lacking, realize the things that I wanted to do more of, that led to more success, that led to more like, I can now do these things. These things can be a lot more complex, but now that I can make things more complex, I can make them even more interesting. I can come up with problems that I can then go and solve. I can do practical things that I can think of. They work in my head, and then they mostly, through hours of debugging, work in the real world as well, which gave me that initial boost of success and satisfaction in it that, I mean, obviously not that brilliant, but that has carried me since. Of I can keep finding new things to learn and do, and I can keep having those things work and make things that are interesting, that I can come up with new problems that I can then solve. I can identify new things in this knowledge frontier that I can learn and then do something with. Which is quite, and then just very quickly circling back to the self-taught point, is that the only way any kind of learning, but especially self-taught learning, works is if it's practical. Like, sure, you can read the book, you can learn about all things C#, or you can give up 3 chapters in and go and do a project with it. And then once you are comfortable with what you know, like actually know, understand, and can use, then go back and there's this thing I can read in the next chapter that actually has with the previous things. That Leeds is quite good with that, having a practical side to education, but that doesn't mean that you can't or shouldn't go beyond that. There is always, like, what you learn in a more formal or more like educational environment, whether that's self-taught or not, there is the only way this really becomes practical and only really sticks in your brain and becomes something that you can do is if you actually go and do it. And so, that's one practical thing that I have found, that learning about anything only really becomes useful if you actually go and do it, which is, again, very simple, but it has been extremely useful in my experience.
Right. When it's actually applied, when it comes together, when you're actually doing when you're learning about something, it's what I had the questions of is like, which one's the better route for me before coming to university, actually, with the degree apprenticeship, or the actual university, because I think the end goal is working towards, I think, the same thing, where I'm hoping to create projects and work on engineering projects. However, it's just a different dynamic, and I weighed it up. And university seemed like a safest choice for me, at least, because it seemed like you're more broader. Actually, you you're not in this domain of like within the company. That's just for me, which is although kind of in a way it was counterintuitive to me, because I'm going to be doing the same thing after I finish this, surely.
So I have some thoughts, and you have later questions on university education in general, but there is more of what university gives you in general than just the education and the learning side.
Yeah.
Even then, there is value in the like formal version of education. This is not a belief necessarily that widely held especially in the software engineering side of engineering, but there is value in that formal setting of education, and there are things that it does allow you to bring some new ideas into. Well, I say new to that specific area, ideas to what you're doing that doing an apprenticeship wouldn't necessarily do that, because you're learning how things are done at that company, not necessarily more like general view. One example of this I think of, I think this was first year, and I don't know if it's still taught, because it's taught on the mechanical engineering side, was like engineering decision-making processes, and specifically the one that I have kept using ever since was the decision matrix, essentially like setting some number of criteria to grade things on, listing your solutions and listing your weights for those criteria, and then scoring your solutions and getting a rough grade for each of those solutions, which is a very good way of mostly objectively, again, not really, but mostly objectively ranking your choices, and then you can have a more in-depth review of the top few, which I have used since in house hunting, which I have used since in a like work environment where this was not a known concept, and it is something that is brought over from mechanical engineering, but is absolutely applicable not just to like general life, but also to like software engineering, where you have like, okay, we have these 5 approaches that we're considering, which is like quite large number of approaches to consider, and to narrow that down to like 1 or 2 that we want to consider more in depth, we can very easily grade them on a few key criteria, and it will give you like, okay, these are the 2 that we should actually consider, which is very much just an example, but it does underline that having a more multidisciplinary view, even if you then go into industry doing things, is still valuable, and still can allow you to look at problems from a very different perspective.
Yeah, I see. Something that you wouldn't have discovered if you were there at the workplace, and then you're doing something, just doing, and then it's maybe with experience probably, but it's not like it's more specific, I think, probably when you're in this. I understand.
Also, if you're doing an apprenticeship, you do need a certain kind of mindset to think about: is this the best way of doing things? Which it's a difficult trade-off, because you don't want to constantly question why everything is done in a certain way, because it's just annoying. And 9 times out of 10, the way things are done for that reason, for a good reason. But the remaining ones, it's a lot easier to identify things that are done in a certain way for historical legacy reasons, but you can come in or you can apply a more analytical or critical mindset that does allow you to identify that, in fact, you can do this process differently, or you can like optimize things or rethink certain processes that still fulfill all of the existing requirements, or you can update those existing requirements, but also allow you to do things better, which I haven't done an internship. I haven't done an apprenticeship. I'm only speculating on this, but I'm guessing that if you are, especially if this ends up being quite dogmatic, it might be a lot more difficult to identify and be be able to bring fresh thoughts into an organization, which university, like few things university does extremely well. That is one of them. Like it does allow you to think critically about problems, not about university itself, but it does allow you to think critically about problems and in a lot more greenfield find solutions to it that are a lot more that can be more that can be a lot better solution than what is considered the best approach. Another specific example, I don't know if I have the model for it. 1 second, I'm going to bring a physical demonstration.
Okay.
So in second year, we had, third year? In one of the years, we had a project in mechanical, which I don't think is done anymore, or not with mechatronics, and you're doing electronics, so it doesn't apply to you, but it's still just a relevant example. There you had about like 30 by 30 centimeter, like 3D printed, like a rough version of a column, and you had to make a robotic arm that drives a ball bearing through it as a like simulation of like magnetically guided, like less invasive version of colonoscopy. It's a fairly interesting project. And the canonical solution was mounting you got two stepper motors, and you had some very limited amount of aluminium box tubing to build the robot out of. And the dogmatic solution, like what they were usually going for is that you have a two-linkage robotic arm that you drive with a belt. And the like dumb solution that you shouldn't fall into is mounting the motor on the end of the arm, because obviously levering is going to just break. And the various clever solutions were, how do you mount the two motors near each other so it can drive that robotic arm?
Yeah.
But instead, what we were able to, or what we were able to do, because the brief only said you have these materials and this is what you need to do, is a solution like this. This is the early prototype I have 3D printed, obviously print and arrive, but which essentially allowed you to mount the two motors very safely. And then the prototype was for showing that we have just enough material to have a rhomboid robotic arm that can fully actuate and can fully like traverse this space, which is a lot easier to test like this than writing some sort of simulation that like checks every point. And this is like, and we have won like double that or like half the time of the next best one, because this was a much superior solution. But that is something that university does allow for. It wasn't build a like two-linkage robotic arm and then try to improve on things. It might be rather like give a broad brief and come up with a solution that works best. And this ended up being a solution that works very well. And so those are the kind of things that academia or they like, or that university is quite good at.
See, fresh, interesting. That was a very in-depth example. Actually, I liked it. Thank you. That was awesome. That actually leads me naturally onto the question of what were your favorite university modules then? If maybe starting from year one onwards, maybe.
I will struggle to come up with specifics, so I will just and they will not be in order. But anything embedded. Mostly, but not entirely because of Craig Evans, but also because it was, again, that like programming and doing things embedded and making things work quite easily that I have very much enjoyed all 4 years of that. And also those also had projects that were broad enough to do interesting things. So second year, I think it has been revamped something, but it had that gamepad, which, again, brief interlude as I dig into my shelf.
No worries.
That is. You know, that's not making that. But...
Join us back after the break.
Yeah, so this gamepad, which is not. This is not what you would see it look like. This has a board inside it, but this is the year I had a 3D printer, so 3D printed some stuff. but yeah, this is again like the brief being just make a game. It did allow to make very. I don't think I will get it right now, but to do very broad things with it, which ended up being like I ended up making a full 3D spaceship game, which was a challenge in its own right because these things have very little memory, and 3D sprites have a lot of memory requirements, and so. But there's again a sort of thing like, yes, if you want to do the bare minimum, you will make Snake and be happy with it. And if that is something that is complex for you, then make Snake, because that like doing the thing that is the most complex for you will be probably the thing that you will learn the most out of. But if you are already quite good at this, doing something trivial just to get a reasonably good mark, at least in my experience, is not really that valuable. Doing something that is actually pushing the limitations of what can be done, whether that be doing some 3D, a friend of mine did a rhythm game, someone did physics simulations, like doing things on the edge of what you know, so you do learn new things, is something that these projects do allow you to do, and that's why I really enjoy those modules. I did also enjoy most things that are hands-on, whether that's the third-year robotics module in computing, having a turtlebot to drive around, the various some of the modules in mechanical that were the more practical ones, not the ones that were not the practical ones. I still have some unpleasant thoughts or unpleasant memories of some mechanical modules. Yeah, and obviously the third and fourth year projects were nice. Yeah, that's mostly it. Also, the one first year module I had with Linfield, that was brilliant, but that was module Linfield, not the content.
What did you have with him, sorry? What module did you have with Edmund?
I think it was like physical electronics. I just remember him explaining how at higher frequencies, capacitors like essentially become transparent by him explaining how like his, I think, daughter and Girl Scouts are running around for various
brownies, the electric, yeah,
exactly that, and there's just something that like A, it's a good explanation, and B, it is not something that you will easily forget, because I think it was like Friday 9 a.m. we were all sitting there miserable, and he's just running around at the board like, okay, good.
I didn't know Edmund teaches mechatronics first year back then. I thought it was just for electrical. That's interesting.
Mechatronics have been changed quite a lot since I did it.
Yeah.
That's why I like if anyone from current mechatronics sees this, I am probably talking about modules that they will not take. Yeah. And like especially some of the mechanical stuff, they have significantly redesigned things since I did, which partially for the better. We did some modules that were, while very useful, a huge pain, and ended up being not that useful. I remember the 2 entire lectures spent on deriving polar coordinates in mechanical, which at the end just turned out, okay, but you can also just use this, and the last 2 hours was completely pointless. And so those modules, I think, have mostly been dropped. They might have been replaced with other things that are not that good. I have no view or authority on that. But yeah, and one thing that I will praise, because on the whole, I have very much enjoyed my experience at Leeds, and one thing that they do quite well is listen to student feedback. Things like, we were the last year that did like app development on the old Macs that I don't think you even have that lab anymore. Like, you have now a robotics lab on first floor that is half robotics lab and half like music lab. That was essentially a lab with just like these MacBooks in them, not MacBooks, but like some Macs in them, and we did a like app development for the iPhone as a second year module, because a few years ago they thought that was a relevant skill. It turned out that wasn't that much the case, especially in Objective-C and not in Swift, but that's a whole separate thing. But because students complained enough about it, they just fully scrapped that. Unfortunately, they scrapped it after us, not before us, but it was a programming module. It was fine. But yeah, so they do listen to students and they do listen to feedback, and tell your course reps to tell them that things are not working, and they will change it in the time scale of universities or in 1 or 2 years. But still, they will change it.
Yeah. I'll be sure to let them know too. Because I actually was interested in going onto the robotics module myself, or the robotics course myself. But as you know, the incorporation of the mechanical side and the School of Computing and the electrical side, it actually was the only, I think, university in that university at Leeds, the only one that required an extra qualification as well, beside all of them, because it combined it. So it's even switching from first year, I think, because it was so different. Some of the modules, they incorporated so many different aspects of it. So yeah, that's interesting to know that the physics was also in the first year as well. That's interesting. That's funny. And he's still doing that as well. He was still doing that explanation years later in the field.
Yeah. That I am not surprised by. And because, CC might have paused, but electrons still move the same way. So
yeah. As you say. Right. Okay. I'm actually interested in your ShockSock experience as president. What that was like. I've read sort of the intro into it of you being handed over, the pat on the back and the not much going. Yeah. So what was that like firsthand?
So it was certainly very interesting. First year I have engaged with ShockSock a bit. I have missed the first big quarterly run, mostly because I couldn't afford it. And so, but there were still some social activities I took part in. But what I did do in first year is I was course rep, and I was quite combative. And there were some modules first year that weren't really working for us, and so I was very much the voice and someone who did get into fights with some lecturer who will remain nameless about the content and the experience of things, which did put me in a very that sort of established me towards the rest of the course as yes, I will do things. And so at around the end of the first year, when a friend of mine knew the then president, who and the entire committee then was leaving. It wasn't a partial handover; it was a full. This committee leaves, and we need someone else to take over. And through them, I got tapped as do I want to be president? Do I want to be president? Sure, sure. I don't know what it means, but I have to take that on. And as you said, handover was I think I got a some document. It was quite brief, and I was okay, enjoy, go figure this out.
Yeah.
And so, to their credit, the union helped with that a lot. They do have, because it is not uncommon for society handovers to look like this, because especially if you're more social society, you're not necessarily into the big formal handover of having new committee shadow the old committee and anything like that. It was just we're gone, enjoy. And so as a union did help with that, and it did also allow us to establish ourselves towards the school as the new face of the society and new doing things, or the us way of doing things. Yeah. And it also allowed us not to have a burden of process of this how things should be done. It was more you go figure out how you want to run this. which is good, which did allow for a lot of leeway for things that I have learned then to put into practice, which even at that point I was casually interested in like management, this sort of things. Like this even came from high school and coaching a team. Like running things, organizing things is something that I'm comfortable with doing. And so doing some, again, self-teaching, reading some books, being able to put that into practice, even in a very small scale, was very useful. But also, it was a daunting task, mostly self-imposed, because our first year was the first year when Robot Fighting League became a thing.
Yeah.
It wasn't under that name. It was just, we are doing Robot Wars, I guess. And it was on a much, much smaller scale. It was like, I think 20 by 20 up to 1 kilo robots. It was absolutely tiny. But it was something that we tried to enter. We didn't end up entering because our robot didn't work. But we did went to, and we had ran the event, and it was an absolute fucking joy. Mm-hmm. And so that was something that we have identified, like that, but bigger, and it's now up to us. And so that first, especially the first initial summer, was spent with a massive proposal to the union, like, please give us lots of money so we can build something proper. And for some reason, they gave us a bunch of money. And so that allowed us to build the arena for it. That allowed us, we obviously ran out of money before we were able to build the roof, so we built that later from different sources of funding. But essentially, we put it on ourselves to have that, but also the regular activities of the society. Run the usual however many a year socials, the part the society takes during the like initial induction week, and all that. It was really quite something. And we did some things around that. We did more merch. We did more. We just tried to do more. And us coming into this end of first year, giving us the second and third year essentially uninterrupted to run the society, did allow us to build Robot Fighting League from nothing, mostly nothing, to something quite significant. It did allow us to run a few really good socials, and it did allow us to be a constant face of, like, we are there for people, and we are there to help, whether that, like, any kind of issues that might be. But obviously, we then faced at the end of that the challenge of, because there was some turnover in the committee itself. Some people have moved positions. Some people left. Some people joined. Like, we had some amount of turnover, not a huge one. There was a fairly continuous committee.
Yeah.
But then we were all at the end of third years. Quite a lot of us were going to industry. Other one of us just didn't want to continue. There were one or two committee members who were like, okay, we're sticking out for next year, but we were, again, like, leading in, like, going into a time when there will be an essential, like, complete refresh of the committee. Mm. This did, however, mean that we, having learned from our experience, we did have a fairly significantly sized handover. I don't know if the document is still around, but current Shock Presidents might still get the quite a few pages of handovers I wrote. Obviously, hopefully changed since then, but it even included like book recommendations. Like, it was comprehensive. But with that in mind, like, trying to avoid it being dogmatic, like not saying like this is how things are done, maybe saying like this is how we did things, so this is what you want to consider doing, but absolutely allowing, like, have a new committee come in and redo everything that we were doing because they were doing it their own way, obviously. And then we have found some competent first years who are like, you look like president material, have this. Yeah. Obviously, it was a very democratic process. It should be, clearly. But yeah, that was more. I was also doing peer mentoring that year, and so I did have some relation to the then first years, and so I was introduced to somebody like, yes, he looks like he might want to run things, and so and then things got obviously handed over. I don't even know how many times since then, but I do hope that that Shockstop is still around and well. And yeah, also run for Shockstock committee. It's fun and a lot of work, but also fun.
This is the exact same thing, you know. I think I was a couple of weeks into, you know, as I spoke to the Shockstock society. I was interested in how things are going here. What is this? What is this about? I've heard from several people who are third years now. Things have changed. All of this sort of thing of Robo Fighting League, and it's restarting again this year. Anyway, they were like, "Yeah, you should run for the Shockstock thing," and I was like, "Really? I think it's really competitive." No one applies. Really, no one applies.
So we have a constitution which has like any significant constitutional changes, new rules, anything like that requires a quorum of some number of your members.
Yeah.
In practice, we had one larger AGM where we had the actual new election where the new committee showed up, and so they were that was most of the quorum of the new committee. But we had when we were establishing we were changing some rule or we were establishing a new I can't actually remember. But I remember we have to call it out of cadence EGM, and it's no one showed up, so we're just there. We voted on it. We went away. Done. It's for most people, and rightly so. University is enough. University is a lot of work. You have a lot of deadlines. You need to learn a lot of things. But if you do have additional capacity, doing things like course rep, peer mentoring, various society rules. There are other societies other than Shockstock, but also Shockstock is the best. I'm not biased, I promise. Doing things like that is extremely, extremely useful. Not just for. And it's good for your CV. It's very good for your CV. Hey, look, I have managed a budget of however many thousands a year, and I had decent responsibilities and chaired committee meetings and all that. But also the practical experience of it. It is hard. I will not lie about that. It can be quite tough at times. Whether that's the social aspect of it, whether that's infighting, whether that's
political
people having problems. Especially at that point. Although we had a committee member specifically for Robot Fighting League, it was myself and that committee member who ran the event, which meant I had a full, a complete handful of responsibilities with that as well. Which, especially running up to the event, was very, very tough. We were essentially between the two of us. We split the announcer slash MC role and the director role, and I was directing because I have the I'm not great with the big shouty, but what that meant essentially the full logistics of running the event was on me, chasing all the competitors, booking all of the fights, figuring out how the event will actually practically work, how we can get the most fights out of this without with having sufficient downtime for everyone to fix their robots. And once we talk about Robot Fighting League, we can talk about that as well. But figuring the logistics of that out was challenging with people showing up last minute. There were two ends of this. There was one end of they come up to the event and say, "Yeah, we have nothing." It's okay, great. I need to move this around. But also people coming to the event, I'm you have not talked to me all year, but I'm here and I have a robot. I'm yeah, thank you. That's great. I mean, I love it. Your robot looks beautiful. Obviously, I will put you in, but also, kindly don't do that. And there were one or two people who did that every year. So every event, so you can count on them, and so you can go up to them and ask, "Will you have something?" And the answer will be, "I will have something." And you can essentially infer from that the quality style of the robot that will be coming in there, which is great. Which is already. A known unknown that you can count with, but also there are also people who show up even the people that you know that you talked with a lot, they show up with I have not one robot but two. Great, thank you, genuinely, they are excellent, but also why? But obviously, as you can hear, I absolutely talk about this lovingly. I absolutely love doing this, and so. Can recommend. Go run for Shockstock. You will probably be uncontested. Or if you write a half-decent manifesto of I will do things Even if you're contested, you'll probably win.
And that actually leads me on to the question of now the robot fighting league. Yeah, and I'm curious actually, what was your method for designing these robots? I mean, designing a robot. I think what my team actually, it was also curious for me to ask as well was the biggest things of how to cut weight down and how to be, I think, still be, strong, still be compact. We had ideas of just being very simple because this is the first time our team is going together. Some of them are so they're third year, so they've probably built a robot in the previous years, but it's been a while, and it's like we could just go for the wedge, but it's like then or like a little simple thing, but I don't know. I'm just curious of your tactic, your strategy on it. We're figuring that out and how to go about it to actually make something come alive on the day.
Yeah. So, full disclosure, I have not officially competed at any point because I ran the event for all those years. I have not officially entered. The year when I wasn't running the event, when I was hoping to compete and have somewhere here a big box of components that was going to turn into a robot, coronavirus happened. Robot fighting got cancelled, obviously, and so big sad. Never actually got to officially enter. I have built a robot once for RFL that was not under my name; it was under someone else. It was essentially a joke entry to hype up the. I don't know if Jake is still competing, but he's a PhD student over in mechanical. He has
he's specialized in combat robot. I think I've heard of them. Yeah, I think I have.
Not specialized, like he has his own PhD. But he has a PhD lab and money to throw at like components and the know how to build. Like he was champion, I think, 3 of the 4 events that we ran roughly. Maybe it was a large number of events. My memory is a bit hazy on the specifics. But yeah, the first time he was entering, we have built a essentially joke robot out of it was mostly 3D printed, mostly scrap materials and like scrap components we found in a bin, like a electronics bin. And I have built that because the person who's going to do the build it got swamped with some other deadlines. So I was like, you're still entering because you're a lot more funny in person.
Yeah.
But like here is the robot that you're entering with. It was like being mostly 3D printed, and on the first hit it got like completely annihilated.
Yeah.
That's what I built. So I wouldn't really base any advice on that.
Yeah.
But what I have done is I have seen every single fight. There are some like easy things to consider. One is when you're design it around the fact that it will get beaten up and you will have somewhere between 10 to 30 minutes to fix it. And so if you have to like dismount your weapon to get access to the internals of the robot, you'll probably have one fight in you. Similarly, things like strain relief, the things that you don't account for when building a regular robot, that it will get hit at a high speed, probably something spinning or ramming or something nasty. And so not having dumb issues like solder unplugging or solder detaching or cables getting loose, getting tangled in things. Like tie everything down, have strain relief, have like account for, because you place 2 components there, it doesn't mean that they will be there by the end of the fight. They will probably move somewhere, quite a different place of the robot. Account for you still working them. But and the like big one magic thing that was found during our time was dye bond, which is essentially like 2 very thin layers of aluminium, like I think like 1 millimeter even less, sandwiched between it is a like thicker bit of plastic. It's used for making like road signs out of. It's just the right combination. It's extremely light, and it's just the right combination of easy to work with, but also is tough to put out against spinners because it's more like it doesn't split. It's more like it tears but gums up weapons quite well. And so it has been the like one big magic material that we have.
What is it called? It's aluminium.
Dye bond.
I'm
just gonna put it into chat here.
Okay, thank you.
Yeah, you can buy it new from eBay, but you can also just find scraps of it if you know the right people. Which I didn't, but I had friends who showed up with like large stacks of diamond. Like, look what I found! It's like, great, can I have some of that? That has been very useful.
Interesting.
Other than that, I mean, it is not a cheap genre, unfortunately. There is some upfront investment in getting some decent components. You can get, I hope, you can still get the core components from ShopSock, such as lipos and radios. Those are the like big expensive things that you have to work around. Finding decent motors is important. Finding decent components, decent wheels has always been a massive challenge. There are some like really high-end stuff that you need to import from the US. You can find some stuff here in the UK on stuff like Robot Shop, but it is very expensive. Or you can find things on Amazon and eBay and cross your fingers that they will not be crap. Don't buy the yellow shitty motors. They are awful. They are a complete waste of money. Yeah. But then there's obviously like finding the right design. The only thing I can recommend there is there are however many seasons of Robot Wars and BattleBots up on YouTube. And I don't know if it's still the case, but the first few competitions of Robot Fighting League is also fully on YouTube. Go look up old fights. Go look at all the designs. Go look at what works, what didn't work. Yeah. There are some absolutely crazy things that you like look at it and say, like, this is not supposed to work, but it works great. We had a team who brought in like some car component that's like it's actually a big fuck of motor, but they salvaged it from a scrapped car that did great because it's just a big spinning thing. It was horrible to drive, but it hit things very hard, and it worked great. But and then also like the robot that I was designed that I have some components for and like a massive amount of CAD for was a like full-on copy of a BattleBots few-time champion, and finding the like right ways to actually build something like that, finding the right components, like realizing that what they did with linear pneumatics, you could do with linear actuators, but linear actuators don't actually like linear actuators are way too like they are very powerful, but they are very slow, and so I found some really like chunky servos that could potentially do something similar. It's never tested. I like half built a prototype, but then all that got scrapped. But the most important advice I can give, this is also like all shop talk and like thinking about what can be done, but by far the most important advice I can give is build something, anything that works somewhat and enter it. Because it is such a different environment compared to, I mean, especially to like university projects, but also just general engineering. Most engineering environments don't involve other things beating the crap out of what you have built.
Yeah.
That doing it and being there and figuring out things like, so this bit survived great, let's do more of that, but also like this thing that he thought was an excellent idea or very clever doesn't actually work in practice because it makes it hard to repair, it doesn't survive hits or whatever it might be. Learning that is a lot more valuable than planning for something and missing events. And so, like, obviously, get it to move. There is nothing more said than something goes in the arena and it just like moves that much and then it gets beaten up.
Yeah.
But if you have something that moves, even if you have no weapons, have like some amount of pushing power, go in and try to push things, or try to run away and outmaneuver someone else. Like, those are all absolutely valid strategies. And even if you go to time, like, you're still marked on style, control, damage, and aggression. You can still win on style and control, and even aggression, even if you do nothing. Obviously, if you don't have any damage, unless the other robot is very bad. But and also there are the hazards. So, like, having anything that you can show up with that you can compete is infinitely more valuable than overthinking it, overanalyzing, overplanning, and not entering. This is actually what we felt for in first year, because we had like it's like very complex spring system and like cams to trigger that, and we had nothing at the end because we just and others who entered with a like slab of wood with some motors came second. It's like that is a lot more valid approach than what we did. It's and also just the atmosphere of being there and taking part in this and seeing your robot do things and like just taking part will give you a lot of motivation of like, okay, I want to do that again, but better this time. But then you have something to build and you have components, you have learned things, you have like experienced things in a combat environment. And so that is infinitely more valuable than like figuring out how to how to build the weapon of your dreams that would go over the weight limit or something like that.
Yeah, that's absolutely. I agree with that. And I think I spoke to an individual as well who was like, just get it moving first. If just simply make the wheels. And then
I remember quite a few times. Like the event officially runs for like 2-3 hours, but we start from like 7 a.m. because like by 10 a.m. we have the entire arena set up, because from 10 a.m. onwards we get competitors in. And I remember having competitors on the day like, yes, that is very nice looking robot. Does the weapon work? No. Does it move? No. It's like, that's great. Or is it going to be moving by 5 p.m.? And the other was and so don't even start to think about weapons, or I would even recommend don't even start to CAD anything until you have strap the motors that you have bought to something and drive it around. And once you are confident it is driving around, it can drive around on various surfaces, because you can't necessarily predict or just like figure out what the surface of the arena is currently, because I think it still would, but it might have changed it. Like figure out what you're driving on and make sure you can drive on it. Because again, like if you can just drive around your opponent, you have a decent chance of winning your first fight. Because unless you have been decided as the cannon fodder for the very big opponent, in which case that happens, and it's unfortunate, but then you had an excellent first fight that you will like look back and like, we lost desperately, but it was so fun, so I don't care. Your first fight will probably be against someone, especially if you're a new competitor, against someone of your same caliber. So someone who may or may not be working fully. And so just working is it sounds like a very low bar, but it's not actually as low, and just hitting that is enough, especially for your first entry. Just go there and have something that works. Even like have it maybe mildly back-shaped, or but like anything that drives around at that point will have a fighting chance.
Yeah. I think that's great advice actually to start off with the bar being. We need to. I think that's important to be realistic with it as well, and slightly ambitious in a way. For me, it feels like that's already ambitious enough. I think to make it.
It's very easy to go in thinking like, I want to win that. I recommend setting realistic, achievable goals where showing up and competing for the first time is an excellent goal, because that is so much more difficult than you would think. Yes, of course, you can, like, once you have done that, you can set your bar more like progressively higher. Hopefully you will have a few years competing. And hopefully, again, they are running 2 events a year, which is what we have found the right cadence to be, which means that you can do like, okay, first event, I have shown up, put something in the arena, and it worked. Done. And the next one, like, okay, how do I win my first fight? And then you can think about, okay, how do I win more than one fight? And how do I, like, and then you can start thinking about the, like, expected competition. Because, like, the other thing that you will see at the event, and even if you don't have anything to enter, just go to the event, like, you will see the variety of robots, from absolute crap heaps to marvels of university engineering. But you can start thinking like, okay, I have a reasonable chance of next time beating that, and that, and maybe that. How do I have the equipment, the weapons, what are their weaknesses? What are they likely to improve by next event? And how can I counter that? How can I beat that? I say all this when I was building, I was aiming for like, I'm back, I would like to win now, but then you can start thinking about the more tactical part of it, of like, okay, like the status quo when I was running things, when I was back, was spinners. Because if you can get a decent amount of weight spinning at a decent amount of rate, it will tear through most things. Because of the weight limit, you will not have like steel. And aluminium is easy to go through. Wood is even easier. And if someone decides to 3D print their armor, yes, that will collapse.
Yeah.
And so spinners was status quo. And so my thinking was, what will beat the spinners? And the design I was going for was what was known in BattleBots, the one that can beat the spinners. The one that's is essentially very low, impenetrable, and had some sort of lifting mechanism which most spinners couldn't recover from. Would it have worked? I have no idea. But it's very much the sort of tactical thing that you will start to think about, like first or second event onwards.
Yeah.
Also, an excellent event strategy is have multiple entries. Like if you have the budget to have components for more than one robot, and if you can get one thing working, you can probably get a second thing working, and you can enter two of them.
Right.
You can enter them in the same arena if the combined weight is in the weight limit. We have not seen huge success of that, but you can have two entries because the competitor organizers will probably love you because you have more things to add to the roster, because the more robots you have in the competition, the more time you have to fix things, which is by far the biggest challenge of running the event.
Yeah.
But also it doubles your learning experience. It doubles the okay, I have two ideas that I can either think about which one would work better, or I can build both, put them both in, and see which one blows up.
Yeah.
And you will not double, but you will have significantly more learning experience, assuming you have a team to fix both of them.
Yeah.
And that's also hugely important. Have a strong team, not only at building things, but also who are there and ready to fix things. Have tools, have spare components. If you can afford it, have spares of everything. That is why, for example, entering with two robots is useful, because you guarantee to have spares of everything because you have two robots, and you might just cannibalize one to be able to use in the other. Yeah. And then you say that will survive, but this one is alive now. Hooray! Which is also a perfectly legitimate strategy. Assuming that you have the time and resources to build to, and assuming you have the time and people to maintain to during the event and fix most of them after fights.
What about the in terms of frame as well? That you would think was that aluminium as well? You guys, because just the base of it, I guess, because you mentioned the armor. That's what I was thinking of.
So, okay, one thing that is a perfectly legitimate approach is not thinking about frame. I remember we had a fairly strong spinner entry. It didn't train, but it was a very strong entry that had no internal frame. It was just die bond cut to shape and with L brackets fixed together.
Right.
Which is very light, because die bond in general is very light, and they had just had some basic internal, maybe a 3D printer or some internal structure to mount things onto.
Yeah.
It worked great. It had some really good fights. The downside of it was that because of the L brackets and the diamond wheel band, you couldn't really disassemble it, and you shouldn't, because the main danger that you're running into, if you're bolting that together, you want to thread lock the shit out of that, because you don't want that to shake loose. And if you have something spinning in there, spinning things will shake things loose. It is totally unavoidable. You want to essentially have as many things screwed down as possible. But that meant for them to do repairs, they had to go in from the front where the weapon was, and things were getting in the way, and this is very difficult to work on. Which is an excellent example of it was very light, very capable, but was very difficult to repair.
Yeah.
Otherwise, you had the gold standard in this is still Jake and his various spinners. He used box tubing and various aluminium plates, like aluminium box tubing and aluminium plates to build a strong frame, and they just had some acrylic on top of that as armor.
Yeah.
It is valid, but it is very difficult to get right, and it's a lot of work.
Yeah.
Like building a frame like that is highly complex. The thing I was planning on was L tubing and rivets, which does mean that like there is no disassembling on the frame, meaning that if there's something you need to be able to reach everything onto the frame. Again, no practical experience. I don't know if it would work, but that was something I was contemplating for my design.
Yeah.
But keeping in mind that it was going to be a very boxy design, for which it probably works better. The other thing, if you want to do more complex shapes, building things out of wood is perfectly valid. You can go much thicker with not that much weight gain, and everything other than the most powerful spinners will be able to resist it. Not like it obviously depends on the wood, not MDF, because MDF is just like wood chips and glue. But even things like plywood, because of the layering, it will have some amount of strength against it. And it's also extremely easy to work with. You can have like very easy hand tools, which is potentially even more important. Like having like you can try to build something out of steel, but if you can't weld and you have no access to welding equipment, then what's the point?
Yeah.
And so you can try some combination of like wood and die bond or just wood itself. You can try to go for aluminium if you can get the materials, whether that's from like go and bag over at mechanical engineering or just buy it off eBay. Various tubing that is available, whether that's square tubes, whether that's L brackets, U brackets, that is absolutely valid. You probably want something pre-made for structural integrity. Just sheet aluminium will not have the kind of integrity that you're looking for, and also if you go thicker, it will be very difficult to work with, and if you go thinner, it will be not very strong.
Yeah.
And so that is a tricky trade-off. But
what about treated? What if they're treated? I was thinking, what if we got some kind of metal, maybe like aluminium, and we treated it like we harden it maybe or something. I don't know if it's even possible. But
theoretically, sure. And if you have someone from mechanical who understands materials, or just go and do research on how you do things like that, theoretically, sure.
Yeah.
Practically, I would foresee problems of the equipment needed for that.
Yeah.
And also, if you're on a budget, and if something goes wrong, you're out of most of your material or a large chunk of your material. And so you have to be able to like do the process up to 3-4 times, assuming that you will make mistakes or you will not get things right. Yeah. And you have wasted maybe weeks trying to make something at the end of it you have nothing to show for.
Yeah.
I wouldn't suggest it for first competition. If we apply this as a rule of, or what you're aiming for is just have something working, I wouldn't necessarily do things like that.
Yeah.
If you're a few competitions in and you're seeing that, okay, my main weakness is my armor, that is absolutely something to consider. Yeah. But at that point, you have something that you think is working, or you have some idea of what worked in the past and what might work in the future, and you can build on that.
Yeah.
And so I wouldn't overcomplicate it.
Right. As simple as possible. Yeah, right, okay.
Yeah.
Okay. And I think I'm actually just curious in some of the last few questions, and I'm cautious of time as well. I don't want to. I
don't mind.
Right. I just wanted to ask a sort of briefly. We touched on, I suppose, on advice on that sort of thing. But what would be your general, I suppose? We touched on this as well, I suppose, in if you have the capability to go if you have some more extra time at university, because my question would have been, what would be your advice for upcoming engineering incoming engineering university students? I think was the question. Do you have else to mention about it, because we briefly touched on it? Or
so pre-university is just, you have no idea how much you don't know, and so just go and find out about things, like expand your horizon of what is out there. It's very easy to, like, especially at the high school pre-university level, to like find a few things that you enjoy, you're good at, and just focus on that, which is hugely valuable. It is essentially what I had. I have, like, I don't want to knock it, but also understanding that there are other things out there that might also be interesting or valuable, that, like, the more you progress through, like, full-time education and then and then full-time work, or if you decide to stay in academia, the more narrower what you work on will become. And so having opportunities like high school and like university, where you're somewhat forced to go out of your comfort zone and be exposed to other things, or having the opportunities to do so, is not something that is easily replicated outside. With something like university, one of my biggest regrets, and it isn't necessarily regret, it's more unfortunate timing, is I didn't really take part in society life in my first 3 years. Mostly because I was way too fucking busy with doing, like, uni and Choksock, and that pretty much took up all my time. But my plan was that, like, it's fine, I do 3 years of this, being extremely busy, doing well in studies and running Choksock and some other things, but I go on placement, get some money, come back and do a bunch of society things. Because having the opportunity for surprisingly low amount of money, like university societies, even the more expensive ones, are relatively cheap compared to doing any of these hobbies, or trying to become any of these hobbies in adulthood, are surprisingly cheap, and you can try things easily without any kind of risk, and a lot more easily compared to, like once you have a job, sure, you can try to find some, like, club or society or course that does the kind of thing that you want to learn, but university gives you such a plethora of options that you don't necessarily get the chance, potentially, like maybe ever again, to have things like that so open and so with the mindset of having new people come in and join and try things for the first time. Like, if you're, like, there are not many, like, beginner sports clubs beyond that. And so at university, there is an expectation of, you might be trying a sport for the first time, and you will, and there is, like, absolutely accepted that you have no experience and you can just join and try it and maybe give up on it and realize that you don't like it. Doing that later is a lot more difficult, because for the most part, most people doing a hobby are not beginners. And so finding a space for you to be crap at something, university is a lot more forgiving with that than anything else beyond. And so while obviously join your local electrical engineering society and give them money, please, but also look at what other societies are there that you might be interested in, that you just want to have a try. Like, I assume the union is still running Give It a Go sessions. Go to a bunch of those, figure out which one of those you would like, because that is the kind of opportunity that you don't really get. Or well, again, all of this is obviously possible, but it is such a free and forgiving environment at university that is a lot more difficult to find outside of it. Also, do well in your studies. It pays off. It's nice. It just like, spend enough time on learning the things that you're there to be learning.
How would you? That's interesting. when did you figure out what works for you in terms of studies at university? That's slightly different to what I was used to when I came to university. Their style of learning here, how they did it on Minerva, how it's done, how this constant repetition of things, which is great. The way it's taught as well. So some of the things I'm getting used to just going to my second semester. How did you sort of feel, because now this break now during Christmas is when I'm really understanding what really works for me in terms of learning, because I have to study for some tests in January and stuff, and it's lectures are all of course done, and now it's bringing it all together, now preparing exams, sort of thing for and it's really interesting because I think what I am learning is how to learn here. And it's I went for a couple of things that haven't worked before when I first, and I'm experiencing now, and maybe it's not going to work this time round as well. So I'm going to try a different thing. So it's that's what I'm currently doing. How did you sort of go through that?
So that's an excellent question, and not one with an easy or straightforward answer. It's on the one hand, I am fortunate enough that I've always was good at learning things. In academic or like study environments, I do remember and recall things fairly easily. Not in other environments. As my fiance, I am forgetting things left, right, and center. But but in an environment like this, I was fortunate enough that I do learn fairly easily. This is not an advice that I can give to others, because this is just obviously this is completely useless. But what you there are two aspects to this. One is, by this time, hopefully you have an understanding of yourself, that what kind of learning works for you, and if not, this is the time to go and figure it out, because this is the last. Well, unless you go into, but even if you go into like more academia, it will be a lot less learning, a lot more research. That is a whole different skill set.
Yeah,
and so figuring out how you can learn things well, what mediums work for you, what techniques, what methods, what time slices, like how all of that works. This is the last time to, again, not last, but this is the last really practical time to figure that out. But that does involve, if you haven't already figuring out, like, you can do some research on what good learning methods there are out there. What are the like main ways people learn, whether that's audio, visual, book learning. Like there are those like core ideas, but figuring out what works for you is what's important, and having an environment where you can assess that is also important. Like
yeah,
what you're talking about, like learning things and then having a practical way of applying it. This is exactly applies here for learning. Like you can learn about learning and then practically apply it to a large corpus of learning material that you will be very much assessed on.
Yeah.
I am personally mostly like audiovisual learner, which means that going for resources like that, just listening to things, or like watching visual demonstrations, whether that's rewatching lectures or just finding stuff on the internet. That has been quite useful, but importantly, like there are limits to any of these techniques, and there are some times when you just sit down and you need to learn things, and you need to like resort back to classical study techniques of just have flashcards if you need, or just do 800 examples until you get them all right, and then do 100 more.
Yeah,
there are cases of that. There is, in some cases, you just have to fall back to just hard work, which is a really shit advice if you're already like spending a lot of time and effort on learning, and saying that, oh, just work harder is obviously not something that is practical, but it's more to say that sometimes it's just hard, and sometimes you just need to spend time and effort on it, and that is what you hope will work.
Yeah.
This is on the one hand. On the other hand, thing to keep in mind, and something that Leeds is very good at, obviously can't speak for the universities, I only go to Leeds, but something I really enjoyed Leeds doing is how much it goes from like theoretical academic learning to hands-on practical things.
Yeah.
I did a master's. In that master's, I had exactly 0 exams. I had maybe 1 or 2 tests, and I had a couple.
In your master's, sorry.
Yeah.
In your master's. Oh, interesting. They don't do any exams.
No.
Oh,
You had 0 exams. You had a bunch of projects, and you had a couple like written essay things, or write a paper as a team, or do a presentation. Like we had so many fucking presentations, but then no exams. Which that might have been just because of COVID. They might have rejigged some things, but practically there is no point in doing exams in 4th year. You're an engineer. You're sure you can try to assess that you have learned certain things, but practically you build something and it works, or you build something and you have to do a presentation about it, how it works. But yeah, and so what you will see, and what does seem like a big struggle at end of first semester, and it will stay like that for the next maybe 2 semesters, is, oh no, exams, tests, like midterm paper, whatever, like, sure, and those are there, but that is somewhat similar to what learning looked like until now. It is still somewhat similar to high school. It's not. It is quite different, especially in the way that you are learning. It is a lot less structured. It's a lot more like, go and learn this. Like give us a lecture, and if you want to actually like learn and understand more of it, go read things or do more like and all that. And there is no like someone looking over you and telling you like, have you learned this thing? It's like, yeah. I told you that thing. I will test you at the end. Good luck.
Mm-hmm.
But that does become a lot less of a concern, like later in 2nd year, 3rd year, especially if you do a master's.
Yeah.
It will be a lot more about what you're learning. You're not learning it because you will be assessed on it. You're learning it so you can use it and apply it. And what you are assessed on is your ability to apply it, which, as far as engineering education goes, I think is excellent.
Mm-hmm.
What it does mean, though, is purely relying on what you learn and expecting that to be enough without doing the suggested extra materials or without going out and learning things yourself. You will do fine, but you will not feel great about it. You will not feel like you have gotten everything out of this. Mm. Using it as a learning platform is hugely valuable and useful. And so at that point, it becomes like learning stops being it stops being the core exercise, and it starts to become the tool to get to knowing things and applying those.
Right.
But and this is why it's quite important in the first like 1 or 2 semesters to figure out how you can learn these things, which might be quite new and it might require new ways of learning. It's like it is a lot more in depth compared to a lot of what you might have done before, and figuring out how to deal with these kind of depths and figuring out like not necessarily having a comprehensive understanding to still being able to apply it is something that becomes more and more useful later down the line. When you for you to get that comprehensive understanding is to go beyond the study materials and study yourself. Which is actually quite interesting because we have a very different kind of experience of university compared to other schools. So my now fiance was doing a business master's while I was doing my mechatronics master's, and her university experience was starkly different to mine, because in engineering, you can have this expectation of there is the study material, you learn that, you get tested on it, and you get a grade between, depending on how well you did, like if you did well from 60 to 100, and if you did terribly, then 60 and under.
Yeah.
And that is not at all the experience outside of engineering. Outside of engineering, you have some lectures, but between those you have a massive amount of reading that is not like a suggestion that if you feel like you should do some more reading because that will deepen your knowledge. No. You need to do all of that reading.
Yeah.
And then following lectures will build on top of that.
Yeah.
Essentially, very little of the actual knowledge needed is paused as a like active learning experience, a lot more like do learning yourself, but also things that is done in university but not done for engineering is grading on a curve. Something that was quite strange to me and took me a few.
The averages. The averages. Who gets the how your grade is higher when the average of the class is that what it's based upon?
Not entirely. It's not anymore an active process. Right. It's more that grades are supposed to like be on a back curve. So the reason the way the first 2-1, 2-2, third grading works is that the median outcome or the average outcome is supposed to be between 2-1 and 2-2.
Yeah.
And the second grade is the like first standard distribution between that median. Yeah. So meaning that if you're in the 2 bracket, you did average within some within one standard deviation.
Yeah.
And then first is everything above that, third is everything below that, and there's some failing cutoff. Which means that the average grade is not supposed to be like you're not supposed to get first. If you're an average student, you're getting 60 on average. And then most people will get between 50 and 70. And going above 70 is an achievement. While in engineering, if you did well, if you studied, if you do a good project, you can absolutely expect to be above 70, even above 80. Like going into the 90s is difficult, but it can still absolutely be done. Going to the 90s in a business degree is unheard of. Which practically it has a lot of issues because what even is the point of anything above 70 if no one gets it? But it is a lot more different.
Yeah.
And so while practically this doesn't really, other than a fun anecdote and better understanding why 1, 2, 1, 2, 1, third is a thing, what this does, what the practical knowledge to take away from here is that is what university is designed to be, and just because engineering isn't like that doesn't mean that you can't do the extra reading, or like even if it's not recommended, there are some very nice libraries. Go get some books, read them. Obviously, that's very easy to say and a lot more difficult to do because there is like I have previously suggested to them also do societies and also do shops. Like there are a million things that you can and should do during university.
Yeah.
And there's also the social side of going out and drinking a lot, which, depending on your flavor of socializing, may or may not be something that you want to do. The only genuine advice I can give is there's so much opportunity during university to learn both in the learning side and the social side and the like broadening your knowledge of the societies. Just make the most of it because there are some excellent opportunities there that seem like a given that are not. Also, you have access to some really clever lecturers. Talk to them. Ask them questions. Ask them smart questions. Otherwise, you will annoy them. Otherwise, you will annoy them. But if you have smart questions to ask, which, if you're that interested, you probably will have, ask them smart questions because you do have access to some world-class researchers that you don't usually get access to.
Yes, that's brilliant advice. That's a comprehensive advice, actually. That's great. Thank you.
Good. I will now take a breath.
It's granted. So this is the last 1 or 2 questions I just wanted to ask about. So where do you see yourself, your future of your work, I suppose, or what projects you would like to be involved in? Those two coupled together, at your work, or where you look to work at, maybe, or sort of thing. Yeah.
So to also there's a bit of context on what I'm currently doing. So my day job is at a company called Trayport. Trayport does commodities trading software, which is essentially, sounds very boring, and on the surface it is essentially like the aggregation software for trading companies to access brokerages and exchanges to trade things such as electricity, natural gas, emissions, all that kind of things.
Right.
And so practically this is a financial technologies company that sees like a massive volume, like 80% of the European volume of trades flowing through it. And then within that, I work on the data analytics product, which essentially takes all of this data volume and stores it in a way that can be fairly easily like read back and used in whether that's analytical, whether that's regulatory, whatever reasons you might want your data back. Where this work becomes extremely interesting is the depth of challenges that such an issue throws up. And then it's not necessarily something it's very different from something like robotics, because you're having a massive and wide range of data coming in, and you need to correctly and flawlessly handle it, because errors in this data is very bad. And obviously it is also on a massive scale. And so that is a absolutely fascinating challenge, and it's a really good company to work at. Slight plug, if someone with a software background wants to do a placement, there is a pretty good place for it. I can do recommendations while I'm there. Which is good, and I'm doing reasonably well there, but it's a like, core, deep software and data engineering position. And what I'm doing on the side is with a company I co-founded called Antisocial Labs, which works in the crypto industry, which it's essentially like consultancy, and projects come with us with their engineering requirements, and we go and build that. It's very different from Trayport in the sense of in Trayport I very much have my like specialty and things that I work on and good at, which is still quite broad within the team, but it is very much focused on the set of products and the platform that we work on. While this consultancy is a massively broad set of problems with a very wild set of client requirements that requires me to be able to do everything. Like it currently has about 12 developers, but I'm still head of development. I'm still taking part in most projects, which means doing everything in the software stack, especially because it's crypto, that includes on-chain smart contract development, backend, front-end, indexing, data, infrastructure, orchestration. There's a huge amount of things I need to know about. And also it's a very exciting leadership position, because I now run a technology department of like about 15 people. That is not really something that is available to people in fairly early in their career. Like in my day job, I'm just a software engineer. I am on a senior track, but I'm not quite there yet. But on the meantime, I'm absolutely like executive level doing things on obviously much smaller scale, lower risk, like nowhere near the turnover, and everyone working there is part-time. But it's still a very different experience. But it does allow me to do two things. One is while with Trayport, I can go deep into problems, deep into software engineering. And social, I can go wide. I can learn about a whole bunch of different things simultaneously and allow me, because they're all self-contained, few months long projects, it does allow me to experiment with new technologies way outside of what I usually work with. And it very much allows me to not get stuck in a few things I'm really good at. It allows me to try new things. I like on the front end, going from React with JS to over to TypeScript, and then looking into Next.js. On the back end, going from Flask to doing a lot more with Express and Fast API. On the front end, working on all three major cloud providers, GCP, AWS, and Azure, at the same time, and understanding their differences on all kinds of different orchestrating platforms and pipelining, GitHub to GitLab to Azure DevOps. It allows me a huge corpus of learning experience, which is extremely useful, but also as that might have been like I always ended up in various leadership positions from quite a while, and so this is something that I do intend on doing more of, whether that's in a senior or staff engineering position, whether that's in a team lead or department lead position, or going beyond that, doing like more executive stuff, CTO kind of things. This does allow me to have a very like hands-on but mostly risk-free way of trying these kind of things, which is hugely valuable and not an experience that you would necessarily get outside, like in a day job, at least not in the first decade of one's career. Like the discovery of timesheets are very valuable, because otherwise I have absolutely no idea who's working on what and if the projects are on budget, which suddenly becomes a lot more important when it's a bottom line to worry about, which is it's not something that you're really exposed to in a standard work setting.
And I guess the question would be, I guess the question would be, what leading from that, or where does you mentioned the two words that you're dabbling in, where you're seeing it from an overview, where you're seeing all aspects of how things are working, and also in a different role, you're also seeing it in depth at a smaller scale, where you're genuinely so I guess where does that lie, or where does the future of some of the projects that you're working on? Because you described, for me, it seems that it's a multitude of things that you described that you're interested in. It's still the curiosity of understanding how things are working at scale and also in depth, which is quite interesting. Because it arouses my curiosity in a way where it's like the process, how it impacts the people that it may impact, and what just trying to figure out where my interests lie as well along with that. So it's interesting. So yeah. What do you think?
Yeah, it is a very unique set of opportunities, because doing, like, we're in a position of doing the high level and broad at a larger scale would not allow me to go in depth. We had at Trayport a fairly higher up engineer who then went on to be head of development, was fairly in depth working on the project before he went into his new role. But it was quite clear that being able to do that was A, extremely rare, and B, still had his time split between his other duties and being able to go deep and like designing and building a system. And so at a scale of even a company of a few hundred people like Trayport, you do not get to have both in a full-time role.
Yeah.
And although obviously I don't know this for sure, but I find it unlikely to have a like full-time a high-level management position, but also being able to go in depth at scale. The place where you can go both wide and deep in the same place is something like a startup, but it comes with huge amounts of instability and just things being constantly on fire. And so having the opportunity to do both in-depth but also broad engineering in two separate positions, which does have the downside of a fairly large amount of time commitment. Like, I do not have a lot of free time. But with that trade-off, having a mostly risk-free startup such as a consultancy, but also having a day job of deep domain-specific engineering, that is a unique combination of opportunities. But it doesn't mean that this is something that's necessarily applicable to others. It's more that identifying the things I want to be doing, the things I want to be learning, and seeking out and pursuing opportunities that allow me to do that while also having a level of stability, which is something like a very boring answer, but it also becomes more and more valuable the more you have other people who might not only depend on you, but depend on you being not suddenly out of a job or not relying on, like, this might work or it might not work. Having a combination of that is truly unique. This doesn't necessarily mean that this would work for anyone else. I do know of, like, most engineers are not interested in might be interested in the going wide, looking at a whole bunch of technologies at once, but you don't necessarily, you rarely get that without the management commitments, which a lot of engineers are not interested in. I am fortunate enough that I am, for whatever reason, but it doesn't necessarily mean that others would also enjoy the, like, management aspects that come with it. But if that is the case, then there are other opportunities out there doing things freelance, where you can just do deep engineering work in domains that you might be familiar with, but also might not. But because it's a freelance position, it is, like, limited in time and scope, and you can try new things that wouldn't necessarily have to live with long term. You can push that problem off to someone else, which is not a nice way of saying this, but it is a reality of it. And that is something I have done because all the social and society stuff what can because of COVID during my masters. I did start doing freelance work during that because honestly I was a bit bored. And so finding what works for you and what you want to learn about is I think the lesson here, not have two jobs and run a dozen people engineering consultancy.
Yeah.
But to answer your previous question of where I see myself going from here, I am not too fussed about the industry specifically. At some point I do want to go back to more, like, hard engineering related. Like, the next role I might go into might be to do with self-driving or applied robotics or whatever else.
Yeah.
Like the other software side, because that is where my skill set is, even within, like, the university setting. I was a lot more happy with the embedded and doing the programming side of things rather than soldering and designing circuits or whatever else. But yeah, like, it's the domain is less of what's important to me. It's more that for some more time I want to do hard deep engineering because it is exciting, but long term I do see myself more on the management, leadership, whatever else side, whether that's starting a company or going into something else or doing both. But also it's so uncertain. It's so, I have this memory during university having, like, big plans and, like, oh, this is what I want to do and what to have. And that's not to say that plans are not useful. Plans are extremely useful. Have things planned out, especially if you're not just by yourself, but even by yourself. Like, have things planned out in year, 5 year, however long increments, but be open to those plans, not at all going how expected, and be able to like ready to plan around those, and then have be ready for plans to change because they will, because a pandemic might show up or something. Yeah.
Right. I know that's actually leading me on to the question of that I think you briefly touched on it, and again is like, what is your personal sort of pursuit in that way? Is a pursuit it's a multitude of things. Once again, it's like pursuit of knowledge, pursuit of learning, or is it pursuit of expertise in a specific domain, or even if it might just be a pursuit of not knowing what the pursuit is a pursuit. So it's I'm just curious of how you think about it, and if that makes it your personal pursuit.
Yeah, it's not something that easy to put a finger on it, but part of it is obviously knowledge and understanding, both deep and wide. It's more like essentially like inverse bell curve of depth, depth of like there are some things I want to know a lot of and have proper expertise in, but understanding that there's only so deep this can go without other sacrifices, and also realizing that there is so many interesting things out there that knowing anything of, even at a high level, is if nothing else interesting. Like not even just within engineering, but obviously engineering itself is a hugely broad discipline and domain. But you have in my case, you have the very depth of like software engineering within that, data related, and within that cloud, and within that like financial things. But also, if you're looking at, you have the cloud bit there, you have general software engineering bit there, but also engineering, you have electrical engineering, you have mechanical things. There are so many disciplines of engineering that are fascinating, that are you wouldn't like that some base knowledge is even useful, and going beyond that, like I have had a fascination with business and business related things, so I now know a fair bit about business and management and finance and how companies are run, both practically and theoretically. Going beyond that, and then essentially all of these become less and less deep, but more and more interesting, from legal to humanities to all that. Is like that's the learning pursuit of things. Like that's one aspect of it. Essentially, like both broadening it and deepening it without trying to forget a lot, or without losing the ability to combine these into new ideas is one aspect of it. Other is somewhat money. It sounds bad, but it is like practically very important, that like pursuing things that don't pay, while might sound noble, it really isn't, and it's very unfortunate that some things that are valuable for humanity are not actually valued. But as engineers, we are extremely fortunate that what we do is seen as valuable, and thus can have a high price, and beyond a certain point, not working for free and being able to stand up for yourself and say, like, okay, if you want my time, here's how much my time costs. And comparing opportunities not just on how interesting or exciting it is, but also on, but how does it pay? That is important, both for having your time valued and having that value be translated to other things, but also as a like a measure of acceptance that what you are doing is viewed as valuable.
Yeah.
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 But I also just want to build cool things, which
Yeah.
is a very engineer thing to say, but I just
Yeah.
like building cool things.
Yeah.
Yeah.
Yeah. I just wanted to, one last question with that is, so based upon, if I didn't forget it, it was mentioning your time that, and oh yeah, it was mentioning actually, why did you feel like this was worth your time in that way? If you could give an answer to that. This conversation,
you mean,
sorry.
It's nice. Obviously, there's a like default human desire to be listened to, and you're a good listener. So,
thank you.
Yeah, I do hope that whoever does it there's very advice heavy, which very easy to do in hindsight. I do hope that there is some actual practical value in this for anyone who might say this. Yeah,
I think so. I agree. I think that was. I personally took away from even just for the robotics side of things. Yeah, absolutely. It was practical. Thank you. And I think that was. I would say that was my last question. And I really enjoyed it, and I do really appreciate your time. It was very valuable.
Absolutely.
So thanks so much. I'll make a stop to the recording. And just to exchange a brief of words.
Please check out the description of this video with more information on the guest, connect with them and myself if you're interested in discuss topics.